Okay, so today we will learn what is a thread deadlock, the last concept. Thread deadlock. Okay, thread deadlock means, okay, it's a situation where two threads, thread 1, thread 2, is waiting to lock objects of each other to complete the execution. To complete the execution and wait for infinite period of time. Okay, thread 1, okay, it's just a situation wherein thread 1 and thread 2, okay, are waiting to lock each other. So T1 is trying to it's waiting to lock T2, and T2 is waiting to lock T1 for completing the execution. For that, they're waiting for infinite number of time. Okay, they're waiting for infinite number of time. So this waiting we can overcome with the help of inter-thread communication. Inter-thread communication. Okay, inter-thread communication. Okay, let me tell you one small example. Suppose assume you are on friend and there is one more friend of yours. Okay, suppose this friend 1, okay, was asked a 10k from friend 2. Okay, friend 1 has been asked a 10k from friend 2. So friend 2 needs 10k, some emergency, something like that. So friend 1 gives 10k. Friend 1 gives 10k to friend 2. Friend 1 gives 10k to friend 2. Okay, gives 10k to friend 2. Now here, see, they have been in the friendship since past 25 years. Okay, assume they have been in friendship from past 25 years. They have seen so much ups and downs together in their friendship. Okay, now, see, this fellow has been given, this fellow has been taken money from this fellow. Okay, so F2, the person, okay, this person has to return the money to the F1. So this fellow is not asking. He also needs money. He also gets some situations. So he also needs amount. Okay. He also needs cash and he is not giving. Why? He don't have cash. Not, it doesn't have cash. He wants, this fellow friend 1 wants friend 2 to return without asking. Friend 1 want friend 2 to return the amount without asking. But friend 1 will not ask. Friend 1 himself will not ask, and friend 2 himself will not give. This is situation. Okay, so friend 1 will not ask, friend 2 will not give until asked. Okay, so there should be one communication going on. So friend 1 will ask one friend as an intermediate person to ask the money from this fellow to give it to friend 1. Okay, so this fellow acts as an inter-thread communication. He acts as a mediator here, but he is an inter-thread communication. Okay, so what happens in inter-thread communication? In inter-thread communication, here when two threads are waiting, this fellow is waiting to receive the amount, this fellow is waiting to give the amount, but he is not giving until it is being asked. This fellow is not asking until it is being given. So they are waiting, okay, to take their money back. This fellow is waiting to take, this fellow is waiting to give, but there is no communication going on. It has been paused. This is a thread deadlock. This is one of the situations of thread deadlock. We need one mediator kind of person to break this this thread deadlock. It is possible with the help of inter-thread communication. Okay, so thread lock can be overcome by inter-thread communication. Okay, so inter-thread communication, how can we achieve this? I just told inter-thread communication. How inter-thread communication means communication between two threads. Okay, inter-thread communication means communication between two threads or multiple threads. Multiple threads are two threads. Excuse me. So usually there will be a communication between two threads. Okay, so inter-thread communication means communication between threads. Now how can we achieve that in our Java? How to achieve it? Okay, so inter-thread communication is achieved by using the methods of object class. Okay, by using methods of object class. Okay, we shall achieve inter-thread communication. So what are the methods from the object class? See, we've just studied few. Okay, so we have to study about wait method, We have to study about one more method called as notify method. One more method, notify all method. Okay, so these are the three methods through which we can achieve inter-thread communication. These are the three methods through which we can achieve our inter-thread communication. Okay, now what this wait method will do? What this wait method will do? This wait method, it will pass the execution. It will pass the execution of the thread and also release all the objects. Release all the object locks held by the given method. This wait is there, no? This wait method, it will pass the execution of the thread and also it will release all the objects locks held by the given method. Okay, next, notify method, it will send notifications. It will send notification to the thread which is in a wait state to resume its execution. Okay, just like here. Okay, so who got this notification? Okay, here someone has to notify this fellow, no? Someone has to notify. That is possible with a notify method. Okay, notify method will notify a mediator so that here this communication goes on and thread deadlock we can overcome. Okay, so this notify method will give a notification to the thread, okay, which is in wait state. It is in wait state, and to resume its execution only it will give notification. Okay, next, notify all method. Suppose one thread is there. Okay, suppose one thread is there, notify method is enough. But suppose multiple threads are there, multiple threads are waiting, multiple threads are waiting for the execution. Okay, they are waiting, multiple threads are waiting. So how can we tell them all that you can resume your execution? How can we tell them all? With the help of notify all method. With the help of notify all method. So with the help of notify all method, we can tell multiple threads. Okay, we can tell multiple threads to resume its execution. Resume its execution. Okay, so it will send, this notify all method will send a notification to all the threads which are in wait state to resume its execution. To resume its execution. Okay, and here, so to understand this, let us go for one program. Okay, so the program is like there are two houses. Okay, there are two houses. Okay, now in the two house there is this is home 1 or O1, O2, object 1, object 2, or home 1, O2. Now here we have a children, that is Smith. Okay, and we have one more child called as Mala. Okay, and Smith is a function, Mala is a function. Okay, next in the home 2 we have John. Okay, and in John home only sister Mala. Okay, we shall take okay, one second. Okay, shall take Sheila here, Sheila, and here we shall take Mala. Okay, so here in the home 1, Smith is there, sister Sheila is there. Home 2, John and Mala. Now suppose it's assume they have fought. Okay, assume these two families has fought. Okay, movie kind of situation. Okay, assume these two families have fought and they're not talking to each other. Okay, and they have been neighbors from so many years. They want to talk to each other, but what's happening? Their egos and all those things are coming in between. So they are waiting until one person talks. Okay, here Smith wants to talk to Mala. Okay, but assume there is one big wall between them and there is one small door wherein only one person can pass. Okay, one person only can pass. Now here, if Smith comes through this and he wants to meet Mala, okay, John has to wait. Okay, so if John wants to come through this door and if he wants to meet Sheila, then Smith has to Wait. Suppose this here. Smith has gone to Mala and John has gone to Sheila. Now, suppose Smith has gone to Mala to talk and John has gone to Sheila to talk because they are neighbors. Now, here, what happens is, now, they came to know that children are communicating through the door in the wall. Okay. So, what they have to do? They have to close it because they have fought. Right? They have fought. So, now someone has to notify. See, if Smith is talking to Sheila and John is talking to, when Smith is talking to Mala and John is talking to Sheila, obviously, someone has to notify them that this is happening, okay, go back to your homes, just like a movie kind of thing. Okay, so in this situation, first any one of them should complete the execution. It's like John should come to his home, okay, or Smith should come to his home. Okay, either John should come to his home or Smith should come to his home. Okay, so this is the situation. Okay, now let us take this situation into our code. Okay, and we shall perform. Means two or more threads looked what? Looked forever. Locked forever. Yeah, it's locked forever, not looked forever. So here, I mean, two threads. For definition, we take two threads. Two threads are waiting to lock each other object, okay, and to complete the execution to come out of that waiting stage. Okay. So here, let us take one program. Okay, so after this, we shall do one more very interesting program for the previous code. I mean, for the previous concept. Okay, let it open. Okay, so let us go to our code. So first project, okay, E23. Multi-threading, yes. So what we shall do is we shall create one class. The class is, okay, home driver. Okay, so in the home driver class, there is home1 as well as home2. So class home1, we shall take a shortcut home1. So in the home1, okay, in the home1, there is Smith and there is Sheila. There is Smith and there is Sheila. Okay, now here. So what we shall do is we shall take a method, that is Smith method. We shall create one function for the Smith, public void Smith, and Smith talks to the other girl, I mean other home girl, that is Mala. Okay, so yes, okay, now what we shall do here, we shall take the other home2, that is O2. Okay, now what we shall do here, Smith will tell hi to his own sister, that is hi Sheila. Hi Sheila. Hi Sheila is told by Smith. Okay. Hi Sheila is told by Smith. Okay. Now after this, next here with the reference of O2 dot, we shall call Mala method from the other class and we shall tell bye to Sheila. Bye Sheila is told by Smith. Okay. Now we shall create one more method, that is Sheila method. Public void Sheila method So here Sheila method is there. Now here Sheila method, Sheila is told hi by, hi Sheila is told by John. Hi Sheila is told by John. That's it. Next, in the other home, okay, in the other home, class O2. Okay, now we have John method and Mala method. So public void John method, wherein home one, from the home one he is talking to, from the home one he is talking to the Sheila. Okay, so John will tell hi Mala to his own sister. He'll tell hi, and shall go. I mean, it is told by John. Hi Mala is told by John. Next, after this, he has to talk to Sheila. So object one dot Sheila method. Then after that, okay, here by to be told by Mala has to be told by John. Okay, so here we shall go for one more method, public void Mala method. So Mala method, who is telling hi Mala, hi Mala is told by the Smith. Okay, now here they want to talk to each other, right? They want to talk to each other. We need a thread. Okay, we will assign the thread to this home one, and we will assign one thread to this home. Okay, we'll assign one thread to at least Smith, at least for this function we shall assign, okay, one thread to the Smith function. We shall assign one more thread to John function. Okay, we shall create the threads first. Okay, so class thread 1. Okay, if you want to make a class as a thread, you have to extend thread class. Okay, next here we here the communication will be between two houses also. Smith is also communicating between two houses and John is also communicating between two houses. So we have to take both home 1 and home 2. Okay, next we shall create one constructor T1 wherein home 1 and home 2 should be initialized. This dot O1 is equal to 1 and this dot O2 is equal to O2. Now here, see, we already know we have to override run method. Okay, we have to override run method in order to give a task for a thread. In order to give a task for a thread, we have to override the run method. Okay, now so here, okay, O1 dot Smith method of O2. O1 dot Smith method of O2. From the O1, the Smith is communicating to the other home person. Okay, next let us take the same thing but for the thread 2. Okay, thread 2 since thread 2 here O2 dot John of O1. John of O1. Okay, so John is from home 2, but he is communicating to the home 1 person. Next, we shall create an object in the home driver. To create an object, we need a main method. So here, let us create an object for O1. New O1 of no argument constructor. Next, O2. O2 is equal to new O2 of no argument constructor. See, we have created an object for homes, but there are threads. We have to create them also. Okay, so T1, variable T1 is equal to new T1 of no argument constructor. So, but here both O1 address and the O2 address you have to pass. Okay, because both the thread is communicating to the both the houses, that is why. Okay, thread 2 T2 is equal to new thread 2 O1 comma O2. Okay, now we have to go for start. T1 dot start, because without start the thread will not start executing. Okay, so T2 dot start. Okay, now see the output neatly. Let us execute the code. Okay, what is this? Hi Sheila is told by Smith. Okay, hi Mala is told by Smith. By Sheila. Next, John is telling hi Mala. Okay, and John is telling hi Sheila, and John is telling bye Mala. So what's happening here? What's happening here? The threads are completely executing. Threads are completely executing. Okay, now what we shall do is, we shall make one thread wait. Okay, we shall make one thread wait. So see the output. Let us execute once again. Okay, if you can see now, you can see that the output is changing. First time we got correct output, but why it keeps changing? Okay, why does it keep changing here? So in order to access the thread with the specific functions, in order to allow the thread to access with the specific functions, we have to go for synchronization. See, proper output we are not getting. We are not getting a proper output. See, it keeps changing. So this is not the correct way. So now what we shall do is, we shall prefix synchronization for all the functions. Okay, synchronized keyword we will prefix for all the function. Then lastly here. Okay, now let us execute the code. Okay, so what's happening here? Hi Mala. Okay, John is telling. Hi Sheila. Smith is telling. Why they are not able to proceed further? See, hi Mala is told by John from the other home. Okay, I mean in the same home. Okay, so John is telling hi to his own sister. Is telling hi to, and Smith is telling hi to his own sister, but they are not proceeding further to have a conversation with the other person home. Okay, the other person from other home. Okay, so why they are not able to communicate, conversate or communicate? Why they are not able to do it? Because they are locked. Okay, because they are locked. In this situation, threads are parallelly executing. This is also executing, and this is also executing. Both Smith and John are executing. How? See, thread 1 is also executing, and thread 2 is also parallelly executing. Two are also executing, and they are waiting for infinite period of time to lock each other object. See, this is what we call it as thread deadlock. Okay, this is what we call it as thread deadlock. Listen carefully, everyone. See, thread deadlock wherein, explain program again. Okay, look into the program once. Okay, so here we have a home 1 wherein we have Smith and Sheila, we have John and Mala. Okay, so what's happening is, without a synchronization they can talk however they want. Okay, like without a proper thread communication. See, there are two homes, home 1, home 2. Here Smith is there, here Sheila is there, here John is there, here Mala is there. Okay, now Smith will tell hi to Sheila, John will tell hi to Mala, then Smith will start communicating with Mala and John will start communicating with Sheila. This is how a threads will communicate with other home objects. If you are assuming these two, thread 1, thread 2, from the objects, this is how they communicate. They have to communicate with the same class function and other class function. Same class function and other class function. They have to communicate. Now here, Okay, if we're taking a threads, okay, these are threads, not a persons. Okay, now this Smith thread trying to talk to Mala, John thread is trying to talk to Sheila. But what we have done here is we have not allowed these two people to get out of the small um, door. Okay, what we have done, we have locked it. It's like, see, Smith we have assigned to thread 1. Okay, and John we have assigned to thread 2. Are you guys understanding? Listen carefully. Smith function we have assigned to thread 1. Smith wants to talk to Mala, but we are not allowing the person to pass through. And John wants to talk to Sheila, but we are not allowing the person to go through that door and to talk to Sheila. Now what's happening? Both are trying to enter at once. Both are trying to enter at once. So what's happening? They are not able to access each other. They are trying to enter, but they're not able to. They're not able to. This is not happening. Okay, and this Smith wants to overcome John, and he has to get out from this first. John wants to get out of this and reach Sheila first. What's happening? They are waiting. Okay, they're waiting. Smith is waiting. John is also waiting. Okay, so what's happening? Smith is waiting. John is waiting. They want to come out of this door, but they don't know whether Smith will come or John will come first. Okay, they don't know whether Smith will come or John will come, because Smith is thread 1, John is thread 2. Okay, whether the thread 1 will enter and go access other class object, or thread 2 will enter or go access other two object. So here what happens? Thread deadlock happened. Okay, wherein thread 1 and thread 2, two threads are there, and they want to lock each other object. Okay, this home object, this thread 2 wants to lock. This home object, this thread 1 wants to lock, but they are not able to lock because execution is not proceeding. Yet there is a deadlock. This is also waiting. Okay, and this is also waiting. Why Smith and John are waiting? To lock each other object. Smith wants to lock John, and John want to lock Smith, because they came to know they're talking to each other's sisters. Okay, Smith wants to lock to John, and John wants to lock to Smith. Okay, now it's not happening. Okay, it's not happening. Now there is a thread deadlock. They are waiting infinite number of times to lock each other object and to communicate, to complete the execution. But what happens? They are angry and they're not able to communicate with each other. They have come into a thread deadlock. Now here what we will do here is, this is the situation. Using the code, this is our situation. The situation is, see, John is telling hi to his own sister, and Smith is telling hi to his own sister, but they are not able to come out of that objects. Okay, they are not able to come out of that objects, and they are not able to lock other objects. Why this is happening? Because of thread deadlock, wherein John is also waiting, and Smith is also waiting. Okay, they wants to enter, but they don't know who will come first. They don't know who will come first. So Smith is also waiting, and John is also waiting to lock each other objects. Now in this situation, now what we will do is, we will make a Smith wait. We will make Smith wait, and and we will allow John to execute. Anyone should, at least anyone should one person should come out of the anger, and they have to talk to each other, right? Like here. Okay, here at least, once again. Okay, so at least one person, okay, they have to come out of anger. So how T1 thread 1 thread 2, now at least one person should enter through that door, and they have to complete the execution. So thread 1, okay, thread 2. So thread 1 wants to come through it, and thread 2 wants to come through it, but they're not able to. Okay, but they're not able to. Why? Because there is a waiting stage. Okay, they're trying to lock each other objects. They are not able to go through it. Now what we will do is, we will wait Smith. We will make the Smith wait, and we'll allow John to execute. That means we will not allow Smith to execute. We will not allow Smith to execute. We will allow John to execute first. So John will execute. Okay, John will execute. Now, after that, John has met Sheila. So, Sheila has to notify that, okay, the execution is done. Okay, this function, this thread execution has been done. That means communication has been done. Okay, it's just a movie scenario. That's it. Okay, so here what we will do is we will make the Smith wait. Okay, we will make the Smith wait. How? After he told hi to Sheila, there is a thread deadlock, right? Now what we will do, we will make Smith wait. So wait, you might get a interrupted exception. So we have to surround it with try and catch. So whichever object is currently executing, thread executing this dot wait method. They have not mentioned proper time, but it's waiting for infinite number of time. And we have to create a catch block for interrupted exception. Okay, to catch interrupted exception. So if they catch interrupted exception, we shall print a stack trace. Okay, tracing of the program. Now here we are waiting. We are making the Smith wait so that John can execute. Here we can do either way. We can make John wait and Smith execute, but we are making the Smith wait for some time. Okay, we are making okay, we are making the Smith wait for some time. Okay, and one more thing is that we are not mentioning time. Okay, one more thing is that we are not mentioning how much time. That is also a problem here. We are not telling how much time he has to wait. Okay, we're just telling he has to wait until when the John spoke to Sheila and come back to the own home. Okay, so here when we are making this thread wait, the John will execute. Okay, so after John has executed, see, let me execute and show you. Let me run the code. We are making one thread wait. See, hi Mala is told by John. Next, hi Sheila is told by Smith. Now John completed execution. John completed execution, but here Smith is waiting. Smith is still waiting. Okay, so let me make you the situation understand. Okay, it's very easy situation. See, it is not good accordingly to the situation, but the concept you have to be clear. Okay, now, so here there is a Smith, there is a John, thread 1, thread 2. So what we are doing, there is a inter-thread communication should go on to avoid thread deadlock. Okay, so here, so from the home one and from the home to here. Now Smith also wants to go and meet Mala. John also wants to go and meet Sheila. Now what we are doing, we are locking Smith. We are locking Smith and we are allowing John to pass through that door and talk to Sheila. Okay, talk to Sheila because now this Smith is locked. Okay, he is waiting. He is waiting. Okay, now he is waiting until this fellow, this thread T2 comes, talks to Sheila and go back. Okay, because suppose there might be a watchman, they'll come to know because they have already fought. Okay, they can't talk, they can't be separated because from many years they were a good neighbors. So suddenly if they don't want to talk, then it will be a little bit difficult. So what happened, Smith didn't go to meet Mala. So what happens, Smith is waiting. First let John come and meet Sheila and go back. Okay, so after that Sheila has to notify John that the communication has been done, so John can go meet Mala and come because there is a watchman, he'll keep seeing. Okay, so here at a time one object is executing. Okay, so thread 1 and a thread 2. Now if one, at least one thread should it should wait. Okay, so thread 1, thread 2, thread 1, thread 2. Now currently the situation is, in the thread 1 Smith is waiting, thread 2 John has completed execution. Okay, earlier both of them executed like in a mixed way. Okay, so both of them executed in a mixed way. Okay, so here here what's happening is, here without synchronization they will talk. Okay, the threads will talk anything. They will communicate with, they'll tell hi to his own sister, bye to his own sister. No, it should not be told. So here now what we are doing is we have to go for synchronization, wherein thread 1 will communicate with this method, thread 2 will communicate with this method. Okay, now that is because of synchronization. No, though it is because of synchronization, we are allowing two threads to execute at the same time. We are allowing two threads to execute at the same time. So what here thread deadlock happened. This thread 1 is waiting for other thread to enter into the door. This thread 2 is waiting other thread to enter into this door. But none of them are entering. None of them are entering. So what we will do, we will make the Smith wait for some time. Until Sheila notifies that John has gone, this Smith will wait. Okay. So here, so John has told hi to his own sister, came here, spoke to Smith's sister, and went back to his own house home. Now Sheila will notify John, I mean Smith. Smith, John has gone. Okay. Smith will start his execution. He'll come to the John's sister. He'll tell hi. He'll talk. Then he'll go back to his own house. This is how we call it as inter-thread communication. Okay, to overcome thread deadlock, and we can overcome this with the help of a method called as notify. Now, who has to notify Smith? One class method, that is Sheila. So here, this dot notify method. Since there are only two threads, we are just going for notify. We are not going for notify all. Okay. So here, just because you have notified, now thread will execute properly. Okay. See, here the complete execution is happening. Here John is telling hi to Mala. Fine. Now hi Sheila is told by Smith. Now here, if the execution stops here, then there is a thread deadlock. But the execution is going on. Execution is going on. What's happening here? Hi Mala is told by John. Hi Sheila is told by Smith. Done. Now inter-thread communication is happening from here. Okay. So Smith is made to wait. Okay. Smith is made to wait. We have seen using wait method. We have made the line number 26. We have made Smith wait. So when Smith is waiting, John will execute. John told hi to Sheila. John told bye to Mala. And after that, Smith starts the execution. Why? Because of this notify method. Line number 38, notify method. Because of this notify method, the Smith will start the execution. He will tell hi Mala and bye Sheila. Bye Sheila. Okay. So here is our complete execution. Let us execute the code again. See here. Is the output changing? Smith, John, Smith, John, John, Smith. Okay. So what's happening here? Okay. John is talking to Mala. Smith is talking to Sheila. Now, John will talk to Sheila because Smith is in a wait stage. So, John has talked to Sheila and John has gone to Smith house. He spoke to Mala. Okay. Then here John has to tell bye Mala. Okay, fine. Now, okay, John work is done. He told bye Mala. Then again here Smith work starts. Smith is telling hi Mala and is telling bye to his sister Sheila because he will go talk to the Mala. Okay, so this is how your inter-thread communications happens. Okay, so in one go you will not understand this code. In one go you will not understand this. You have to practice the code. Without synchronization, how they both access? Without synchronization, execution is possible, but not a proper output you will get. Okay, you'll not get a proper output without synchronization. We have seen many programs we have seen. Next program also we will see. Without synchronization, it is not possible for the threads to execute properly because thread has a thread scheduler. Okay, thread time scheduler in the CPU wherein it will allot the time. Okay, it will allot some time for execution of a thread because based on CPU timings, the execution is happening and threads even don't know what time they will execute. Based on thread scheduler, they keep executing because we have not applied a law called as synchronization. If we apply synchronization, accordingly they will execute. Okay. Okay, now let me tell you one more time here what's happening. One last time I will tell you. See, I know it's little bit confusing. You guys have to execute the code. Okay. Then you'll get it completely. Okay, I'll explain the scenario again. So what's happening is Okay, there are two home. Okay, there are two home. Home 1, home 2. Listen very carefully. Don't get confused. Listen very, very carefully. This is home 1, home 2. Okay, now in the home 1, we have two functions, Smith and Sheila. Home 2, John and Mala. Okay, so here let us write the function Smith, Sheila, John, Mala. Now here, okay, now here. So now here they have fought. Okay, just for the sake, listen carefully. Now, so this is the wall, okay, and this is a small door. Listen carefully. Now Smith and this John, they are all friends. Okay, they two brothers and sisters. They are all friends. Now they have fought, and now just understand this situation in the code. The situation is Smith has to go talk to Mala, and John has to go talk to Sheila. That is the situation. Smith has to go talk to Mala, and John has to go talk to Sheila. So that is what they wanted. That is what finally they want. But here what's happening? Here what's happening? Here, since we don't have any synchronization, Smith is talking to John, Smith is talking to Mala, John is talking to Sheila, John is talking to Smith. So there is so much confusion going on. Okay, without synchronization. If synchronization is there, Smith will talk only to Mala and John will talk only to Sheila. So, I mean, first Smith will tell hi to Sheila, then hi to Mala by telling bye to Sheila. Then John will tell hi Mala and he will tell bye to Mala and then tell hi to Sheila. Okay. So first they greet their sister, then they get out of the house to meet their friends. Okay. Now here, listen carefully. So since we have allowed Smith to go through this door and talk to Mala, and we have also allowed John to go through this door and talk to Sheila. At a time, both are executing and they are waiting. See, two objects at a time can't execute. Okay, they need to wait. Okay, but parallelly both are executing. Now, for this Smith, we have applied one thread 1. Okay, for the John, we have applied one thread 2. Okay, because Smith has to go talk to Mala, that is one task that is applied to thread 1, and John has to go talk to the Sheila, and for that we have assigned one more thread called as T2. Now T1 has to execute and T2 also has to execute. Two threads now parallelly they are not able to execute. Okay, now what we have to do, we have to go for synchronization. So after synchronization here, what's happening, Smith is trying to, I mean this thread 1 is trying to go through this door and talk to Mala. John is trying to go through this door and talk to Sheila, but it's not happening because thread 1 is here and thread 2 is here. They're both angry. Okay, now here what happens, this is called as thread deadlock. This fellow is not ready to come this side, this fellow is not ready to come this side, but they're ready to fight. They want to complete execution, they want to go out, but since they are seeing each other, they don't want to come out. This is called as thread deadlock. This is called as thread deadlock. So at a time, only one person, okay, one person can come out of this door. Okay, two person can't come out. So they have planned nicely. What they have planned? They have planned like first. Okay, so they went in. So first, what to do is Smith has to wait for some time. Meanwhile, John will enter the door, tell hi Sheila. I mean, he will talk to Sheila, and he will come back. Then after that, this door will be empty, and then this Smith can go through the door and talk to Mala and get out. So if see here, listen carefully, they have come to one understanding that first let John go through this door, because at a time one person only can go through this door. John, let him go through this door, talk to Sheila and go back. Let John come to the door, talk to Sheila and go back. And Sheila, after John going back, Sheila has to notify Smith. But if Sheila is not notifying, Smith will wait for infinite number of time. That is, this thread one is a waiting thread because we made this thread to wait for infinite time. Okay. So after John came, talked to Sheila, went back. Okay. Sheila has to notify Smith that John has completed his execution. I mean, the John has completed the conversation. Now Smith can go talk to the friend. Smith will now go enter through that door and he'll go talk to Mala and come out. So this interthread is communication is possible through the notify method. Since only one thread was waiting, we use notify method. If multiple threads were waiting, we were used to use notify all. Okay. So this is the scenario. You'll understand much better once if you go to the notes. Okay. You guys got an idea? Why notify we use? Why wait we use? Okay. Why synchronized keyword we use? You guys got an idea? Everyone? Okay. So okay, guys, fine. You have to execute the code, then only you'll understand. Okay, we are not Einsteins to understand everything at one go. So you'll understand, but it will take some time. Practice the code 1-2 times, you'll understand. Okay. So one more thing you have to know that there is a feature called as Java garbage collector. You know, can you tell me what does a garbage collector will do? Java garbage collector will do? Anyone? What does Java garbage collector will do? I have told you this before also. Java garbage collector. Yes, clear the object for space. No, space. What is the end? What is the use? Clearing a space for speeding up execution. For speeding up execution. Okay, let me tell you why. You're correct only. It will clear the space for execution of the object. No. Trim method is only used for that particular string. Okay. Trim to size method, those are yes, for speedily execution only. But for whole memory, I'm telling, for whole execution memory, not only for one object, whole execution memory, we have a member called as Java garbage collector. Okay, we have a member called as Java garbage collector. Okay, now what does that collector will do? Java garbage collector, what that collector will do? Okay, let us know. Okay, so here Java garbage collector. Okay, so Java garbage collector means, okay, it is a feature in our JVM. Okay, in Java garbage means here whatever the memory, okay, whatever memory you have, in that memory if you have unreferenced objects, okay, in our memory if you have unreferenced objects, okay, this garbage collector will enter into the memory. It will take off unreferenced object and making space for execution. It will make space for execution. As the memory is more, the execution will speed. Okay, so the execution memory is directly proportional to the speed of execution. Execution memory is directly proportional to speed of execution. If execution memory is more, the speed of execution is also more. If execution memory is less, the speed of execution also will become less. See, if you have not understood this, see, suppose you have one phone, okay, the RAM itself is or ROM itself is some little GB, okay. Now okay, wait. So here, now what happens? Now in your phone, if you have less space, if you are taking more selfies and pics, okay, the memory gets full and your phone gets hanged. Phone will get hanged. Why? Because the memory has been full. For execution, we need memory. Okay, we need memory in for execution. So now what we have to do? We have to come across our Java garbage collector. So we don't have to call anyone here. You don't have to call a Java garbage collector, come do the work and go. No, you don't have to tell anything. Here it is initiated by JVM. JVM will take care. So whenever this memory feels like it is getting full, okay, and there are some waste elements, That time this Java garbage collector will come into existence and it will remove the unreferenced objects or waste memory. Okay, waste memory or unreferenced objects, now it will take off by making a space for speedy execution. That is why in Java we don't have to specially have any members. We don't have any special members to remove the unreferenced object. But in other languages, if we see, so in C language there is a method called as free method. This we have to use to clear off the memory. Okay, and here in C++ we have one more method called as delete method. Okay, so this is a problem. Here in Java we don't have to use it. You should know that Java is an updated part of C and C++. Java is an updated part of C and C++, but it's advanced. You need C and C++ for data structures and all, you should know. But if you know, that's more better. If you know Java, that's more better. Okay. Now, here in our Java, there is automatic memory management. Automatic memory management. Okay. So, this is what we called as automatic memory management, which is provided by Java. Okay, that is possible with the help of Java garbage collector. Java garbage collector has automatic memory management power which is initiated by JVM. Okay, now advantage of garbage collector, you know that it makes Java memory efficient because garbage collector removes the unreferenced object, okay, from the heap memory. Okay, now one more thing you have to know. Okay, one more thing you have to know, there is one more example which you have to know for your previous this data inconvenience. Okay, we have to know one more example for that. Okay, so meanwhile okay, so meanwhile, can anyone tell me what is the use of synchronized keyword? What is the use of synchronized keyword? Meanwhile, anyone tell me? Synchronized keyword. We will complete concepts today. Synchronized keyword. You have so much leave. I hope you guys have studied synchronized keyword. I have told you the use. I don't want definition. Just what is the use of it, you can tell. Anyone? Yes, we use for proper output, no change in output. Yes, if you want a proper output, that too when you're using threads. Okay. That too, when you're using threads, if you want a proper output, you go for synchronized keyword. Yes, correct. That means to achieve the uh, normal synchronization, it means like one object, okay, should be able to access. I mean, one object should be able to access by only one thread at a time. Okay, one thread should access one object at a time. So we go for synchronization. Okay. Okay. Okay, synchronize means proper order. Yes. Okay, so you have asked one doubt, right? One second. Okay, so you have asked the difference between what is that? Parallel and serial garbage collector. See, the parallel garbage collector is it's like serial collector. Okay, so one difference between these two collectors are like this parallel collector has multiple threads. Okay, multiple threads, okay, that are used to speed up garbage collection. For doing this task also, we assign multiple threads to this parallel collector. Okay, here okay, see, parallel garbage collector, it's the default garbage collector we use. Okay, not the serial garbage collector. So parallel garbage collector is a default collector which is used by our Java. Until Java 5, we used serial garbage collector. But after Java 5, We are using parallel garbage collector to speed up the garbage collection process. This for taking of the unused objects or unreferenced object fastly, we have assigned few threads to this parallel garbage collector so that there will be a speedy execution, and the objects, unwanted objects, will be removed faster. So here by default after Java 5 we have a parallel garbage collector. Okay, and so here serial garbage collector is little bit slow, okay, until Java 5 we used. After that we are using parallel because we want a speedy memory removal for execution. Okay, so okay, so this is the thing. Okay, and here the one main difference you have to know that, okay, parallel and serial, parallel garbage collector and serial garbage collector. See, serial garbage collector until Java 5 used, okay, and parallel garbage collector after Java, okay, like Java 6, from Java 6 from later on used. Okay, so parallel garbage collector, we assign multiple threads to speed up the process. Okay, for we assign multiple threads to speed up the garbage collection. Okay, but here we don't use any threads. Okay, we don't use any threads, that's the difference. And one more thing is, when we are using multiple threads, the execution speed will be more. Okay, so using multiple threads we perform this garbage collection. Okay, I mean by default it is there after Java 5. And in the serial, okay, there will be only one thread performing. Okay, one thread only will be performing in the serial garbage collector. But if you have multiple threads, the parallelly multi-threading can happen, and easily execution will be, I mean the memory space will be made available for execution. Okay, so by default currently whatever we have, the default garbage collector is a parallel garbage collector. Okay, okay, okay guys, so I thought of doing one more program for your data inconvenience, wherein we will uh, execute our name object. So one thread will read the name, wherein one more thread will write the name. Okay, okay, we shall do it. So till now, have you understood everything? We shall proceed with the next one more program, because we have enough time. We will do one more program and the data inconvenience. Are you guys clear with today's concept? Shall we go for next? Everyone? Okay. Okay, so next program is like, you will have a name object. Okay, so this is, we are coming back to a previous concept. Okay, 1 second. Guys, 1 second. Guys, just a minute. Excuse me, I was on a call. Excuse me. Yeah. Okay. Okay, let me explain you. Very interesting thing. This program is very interesting. Okay, let me tell you. We are going back to a previous concept, data inconvenience or data inconsistency. We also call it as a race condition. Because of race condition only we get data inconvenience. Okay, now here, suppose we take one object and the object's name is one hero name. Suppose if you take Rajnikant. Okay, now this object is having one name called as Rajnikant. Now what we will do, we will assign one thread to change the, I mean read the name, and we'll assign one more thread to change the name. Listen carefully. One thread to read whatever the name is, one thread to edit or write the name, that means to change the name. Now without synchronization they will mess up, really they will mess up. Synchronization allows only one thread at a time to access the object. Okay, access the name object. Suppose this is a name object, okay, one thread should execute, either one thread should read completely and get out, or one thread should write or change the name completely and get out. Okay, without thread synchronization, that is the problem we will face, and with synchronization we can correctly read and we can correctly write. Okay, so now here, um okay, so we shall take first the name object class and we shall create the threads. Okay. Okay, so meanwhile, our counselor is here. Okay, we shall resume back after requirement announcement. Yes, Pushpa, I can carry on.
Thank you, ma'am. Good evening, guys. This is Pushpa from announcement team. Guys, is my voice is audible to everyone? Guys, please respond. I'm audible. Okay, thank you. Guys, today I'm here to announce the requirements and new batch updates. I will be sharing my screen now, guys. Guys, I hope screen is visible to everyone. This is testing requirement. Please take a snap of this slide. Guys, for the first requirement, only male candidates are eligible, and those are completed manual and automation. They can apply. Okay, and guys, for the second requirement, those are completed automation testing. They can apply. It is for 2020 to 2023 pass out students. And guys, for the third requirement, designation is validation engineer. Those are completed both manual and automation testing. They can apply. It is only for BE BTech students. Those are passed out in 2022 and 2023. And guys, for the last requirement, designation is QA tester. Those are completed manual and automation. They can apply. It is only for 2023 pass out students, and interview date is 29th October, guys. Okay, guys, I am moving to the other requirements. Guys, this is a development requirement. Please take a snap of this slide. Guys, for the second requirement, interview date is 27th October. Time will be 10 a.m. For this, core Java and Ops concept should be completed, and you need to submit all original certificate. Okay. And guys, for the fifth requirement, interview date is 26th. For this, SQL completed students are eligible, guys. And guys, for the last requirement, there is a separate link. I'm already shared this link in broadcast. Guys, for this last requirement only, you need to register yourself through this link. Okay, guys. If you are eligible for any of the requirement, you need to register. Sorry, you need to share your details to the HR in QTalk app. Okay, and these requirements also posted in QTalk app, guys. So please contact your HR for further clarification. Okay, guys, I stop sharing my screen now. Guys, I got only 20 responses, guys. Remaining people, please fill the form. Guys, I'm already shared a new batch updates in broadcast. I hope everyone received. Guys, Java Selenium new batches will be starting from 26th October. Time will be 7 p.m. to 9 p.m. Guys, for this Java Selenium, Java should be completed and it is only for testing student. Okay, guys, this batch will be handled by Shobha ma'am. And guys, API new batch will be starting from 26th October. Time will be 7 a.m. to 9 a.m. Guys, for this API batch, manual should be completed and it is only for testing student and it is only for experienced student. Okay, and this batch will be handled by Chaitra ma'am. Guys, if you have any queries, please let me know, guys. Preeti, we don't get any update regarding that. When we get, we will update you, or else contact your counselor once they will let you know. Okay. Okay. Preeti, for the next batch, you need to wait for 25 days. Okay. Once contact your counselor, they will let you know. Guys, any doubts? Okay, guys, these are updates for today class. Yeah, yeah, Pooja. Selenium class duration will be 1 month. Okay. Yes, Preeti, Java Selenium class will be starting from tomorrow. That will be time will be 7 p.m. to 9 p.m. Okay. Oh, okay. Any other queries? Okay, guys. These are updates for today class. Thank you, guys. Thank you, ma'am.
Okay, guys, we shall resume back quickly. Okay, now. Okay, so now what we shall do is we shall create one class wherein we shall create one name object class. Okay, so one name object name itself we shall take it as a name object. Let us keep it aside for a time being. Okay, now what we shall do is we will create one class called as task. Okay, because in this class we will be assigning tasks. We will be taking one name, we'll assign one function for reading, we'll assign one function for writing. Okay, so what we'll do is we'll just take one name here. String name is equal to, we'll take the name that is Rajnikant. Okay, now we will take one thread. Okay, we will take one thread. Okay, task one thread to read the name character by character, character by character. Okay, next here, now what we shall do, we will create one function. Okay, the function is read method. Public void read method. In the read method, now we shall go for loop, because using for loop and a caret method we can easily read everything. Okay, so for loop, now int I is equal to index 0, I should be less than name dot length minus 1. Okay, because it's less than, just can take less than or equal to name dot length. Okay, or we can take less than name dot length minus 1. Okay, and I plus plus. Now here we shall go for printing the name with a print statement. Okay, so here we shall go for name variable dot char out of index I. Now we should know which thread is currently getting executed, right? So here we shall print the thread name, thread dot current thread dot, okay, get name method. Okay, here we shall get the thread name. Okay, next here, this is a task 1. Now after this we shall go for task 2. Task 2, task 2 to to write the name, to write the name. Task 2 is to write the name. Write the name is obviously we'll create one function to write. Public void write method wherein go for string str. Now name variable is equal to, we shall initialize with the str here, and we shall also tell which thread is currently getting executed and what is the return name here. Okay, so thread dot current thread dot get name. Okay, and here now whatever the name we get here, now that will be the return name. Okay, is return name. Now here we have write method, here we have read method. Okay, both write and read method we have. Next what we have to do, see, read is a function, okay, and write is one function. If this function has to come into an existence, we have to assign two threads, one thread for read and one thread for writing the name object. Now we shall create one threads class. Okay, t1 t2 are already there. Okay, so what we shall do is person1 thread. Okay, if you want to make the person1 thread to be a thread, extend thread class. Next, we'll take the task variable task t. Now we shall create one constructor person1 thread1. Okay, task, and here we shall initialize this dot t is equal to t. Just creating an object for the object for the thread. Okay, and constructor for the thread. Now next, if you want to give a task, it is possible only to give through the run method. Whatever you do, create an object, go for start method, stop method, do whatever you want. But task, if you want to assign to thread, go for run method. Okay. Next, variable t dot. Now we have to assign one reading task for this person1. Person1 should read the data, name object data. Same thing, we shall go for person2. Go for person2, person2. Okay. And here t dot write the name. Okay, so in the name position, we shall take. Okay, I'll take my name because he's a great hero, so I'll take my name. I want to replace my name. Okay, so here one more thread I have assigned for the person2 to change the name. Okay, I want to change name. Okay, now okay, now name has been taken. Now next what we shall do is we have to um, create an object for the task. First we have to create an object for the task, then we have to create an object for these two threads, then we have to start the execution. Okay, so we shall go for main method. After going for main method here, next go for object creation of the task. E is equal to new task of no argument constructor. Next, person1 e1 is equal to new person1 of year. To start execution, so p1 dot start. Same thing for the person2 thread. So person2 p2 is equal to new person2 t and p2 dot start. Fine. Now we have to know which thread is currently there. I mean, which thread has executed and what is the return name. Okay, so thread dot current thread name. Okay. Okay, we shall execute the code first and we shall write here that thread dot. We have to know what is the return name here. So we shall change this return name. Okay. Okay, fine. Now we shall go here and we shall tell. Okay, wait a second. We'll go for thread dot current thread dot get name of the thread, and here we shall get the t dot name variable. Okay. Now let us execute the code, and somewhere error is there. Okay. Okay, main, no such method error, valid, oops. Okay. So here we are getting interrupted exception. Why we are getting interrupted exception? We shall see. Okay, so read write. Okay, P1, P2. So what's happening in P1 here? Already defined. Okay. Okay, so what we shall do? P2 we will take, and or we shall take P3. which will okay, P3 will change the name. Okay, fine. Now here, um, okay, so we shall change here also P3. Also P3 we shall change here also. Okay, now let us start executing. Okay. So here if you are seeing execution, thread 0 is reading the name Rajnikant. Okay, and main method is reading the name Rajnikant, and Likita is a return name. Return name we are getting properly, but okay. So here um okay, so here we are not getting a proper output because there is no synchronization. See how many every times we execute. What are we getting? Thread 0, Likita is a return name. Main thread name is main. Okay, Rajnikant is the name, and Likhit. Where is A? A is not there. So inconvenient data. Okay, now let us execute again. What is this? Thread 0, Likita is return name, and main Rajnikant. What is this? In the main method, if you are executing in main method, the last edited name should be my name. But here what you are getting? You are getting Rajnikant. Okay, you are getting the name Rajnikant here. So you should not get that. Should not get that. See, let us execute once more. Okay, so thread 0. Okay, we shall take off this thread. Thread 0 again. We shall get it. No problem. Okay, now Rajnikant is a name we have read from the main. It is Rajnikant only. Rikita as a written name. But we have to Rikita as a written name. Fine. But under main method also you have to get Likita only. But still you're getting Rajnikant. It means the threads are not executing properly. So we shall make it as a synchronized. Okay, we shall make it as a synchronized. Here also we shall make it as synchronized. Okay, we shall make it as synchronized. Now let us execute. Okay. So Rajnikant main, Rajnikant Likita is written name. Fine. Let us execute again. Okay. Okay. Still we are getting Rajnikant only. So what we shall do here is, okay, Rajnikant main, Rajnikant written. Okay. So here now what we will do is we shall make one thread delay. Okay. See, both are synchronized. So now I am getting full name. When you are synchronized, the name is not getting changed. Okay, Rajnikant, your name is not changing. Here one word is missing. Okay, but here the main is reading complete name, and here my name is coming complete clear because of synchronization. But here the problem is one thread has to wait because though both threads are executing parallelly, so this problem is happening. So what we shall do, we shall make one thread wait. So thread 2 we will wait. Okay, we'll make wait. First let thread 1 read and go, then we shall wait for thread 2. So try. So we have to make the thread sleep. Okay, earlier we used wait, now we shall use sleep. So sleep method is from thread class. Thread dot sleep method. See, 1 second. Okay, so how much is 1 second? 1 second is equal to how many? How many milliseconds? Oh, that is because of console memory. Okay, like console. There are also this. If you don't know, this Eclipse is also built on Java only. Eclipse is built on Java only. So previous thread first it will execute. Previous thread output. Okay. So first previous thread. Okay, yes, some error is there. Fine. Previous thread output it will execute first. Okay. Then it will execute the current output because of threads. Because of threads are executing, right? There is no storage here. But parallelly threads are executing. Okay. Parallelly threads are executing. So first what happens? See, when there is no input, no, like suppose we have not written main method here and we keep executing code, what we will get? We will get previous code output only we will get. Okay, suppose, okay, one second. Okay, now suppose if you don't have this main method, okay, suppose we don't have this main method, let us execute the code. Okay, main method not found you're getting, but if you're having main method and if you're done, okay, I mean without main method if you do you'll get it. But sometimes what happens, you will excuse me, you will get a previous output because of threads, that is for sure you will get it. So when we're executing here, surely you'll get a previous output first, okay, because of threads. So the thread has to execute completely, it is taking some time, meanwhile the previous output is coming, that's all. Because it's taking some time to execute, some milliseconds, so previous output is coming, later the proper output is coming. Okay, so here we shall execute the code. Okay, so we have written less than -1, fine. We have read the name here, okay, and in the main method the name is Ajnikant. Okay, now what we shall do, shall go for one println statement here after writing. Okay, so name is, we shall write here that, okay, now we shall have a validated output, current name. Okay, now let us execute the code. Okay, so current name is Rajnikant and changed name, we shall have a meaningful output. Okay, changed name. Okay, shall save, let us execute again. Okay, what error do we have here? Okay, so this happens sometimes. Okay, okay, it's taking some time, so it's still prepare, I mean it's giving the previous output. See, console, it will not have memory, but still previous output is there. Okay, after closing the this Eclipse application, but if you open again you will not find anything in console, but currently the previous program output you will see. So there is some problem here. We shall close this, we shall open them again. Let it open. Okay, now can you see previous output? Can you see previous output? No, we have closed the application itself. Let's execute the code. Now, how come you got directly the current output? See, if you execute, now you're getting current output because there was a previous memory. Okay, I mean the output, previous output was there. If this code didn't execute properly, previous output is there. It will show that only. Okay, now listen everyone. Current name is, okay. Um. Okay, so here where we have, okay. Okay, so second one we are trying to do first. Okay. Okay, so there is no weighting of the threads here. So here there is no weightage. So current name itself is Rajnikant. Okay, whatever the name we have read is Rajnikant in the main, and change in name is Likita. Change in name it is showing. Okay, change in name it is showing. Okay, but in the main it is still Rajnikant only. Okay, now here so current name dot character type. So you'll get the name, and after that here fine. Okay, change in name it is changing. Changing is done. Okay, from the thread to here the name is changing. Okay, name is changing properly, but okay, 1 second. So what output we have to get here is okay, let me remove this first. Let us run the code. So we have to get current name is Rajnikant, and changed name is Likita. And in the main method also, the changed name should be Likita because we have already changed. But that is not happening here. Let us see why. So current name is Rajnikant, fine. Changed name is Likita, fine. Now here, okay. So if you are printing from the main method, okay, from the main method here, we are just trying to print the name. In the main method, with the help of this reference, with the task class, if the name has not changed, then the threads have failed. Okay, if the name is shown again, then surely threads are failed. So in the main, we are still getting Rajnikant. That means what? And thread is executing fully, it is not allowing other thread to execute fastly. So what we will do, we will make one thread wait. Okay, so we will make the person to thread wait. Now try sleep we shall go for. I was asking you one question. How many milliseconds are there in 1 second? How many milliseconds are there in 1 second? How many milliseconds are there in 1 second? Very good. Okay, so there are 1000 milliseconds in 1 second. Okay, now here, now we shall take 1000 milliseconds to delay the output by 1 second, and so that the output will be proper. Excuse me. Here we might get an interpret exception. So let us handle it with the help of try and catch. Okay, next. After making one thread wait, which thread we are making wait? See in the output, the thread to read, okay, person to thread, okay, we are making person, where is it? Okay, so yeah, so we are making the one person thread to wait and one person thread to execute. Okay, so now we got a proper output. Okay, so current name is Rajnikant, change name is Likita, and in the main the current name is Likita itself. Because the name is already changed to Likita, it should be Likita here. Okay, now what we have done like that, see we have made one thread to sleep. Okay, we have made one thread to sleep. Excuse me. So what was happening is one thread was reading the name, okay, and one thread was changing the name, but after one more thread got executed. See here, this changing name was not waiting. We have made the person to wait. See, person to what we have here on person to, it is to write the name. So we made the person to wait for some time. See, for person to only we are making it wait. For person to, we are making it wait for 1 second. We are making person to wait for 1 second. After making it wait for 1 second, okay, meanwhile the other thread, okay, meanwhile the other thread to read the data, it is reading and it is executing. So after reading, okay, this person thread will start executing first. So person 3 will read the data first. Okay, person 3 will read the data first. After reading, it will tell current name is Rajnikant. After that, 1 second gap will be there. 1 second gap will be there. Meanwhile, person 2 thread will change the name. After 1 second, person 2 will change the name, and 1 second, after 1 second, person 2 will change the name. After that, if we get to know what is there in the name variable, it is the Likita. Okay, so let me tell you how it's happening. So there is person 3 and person 2. So person 2 which we are assigned for person 2, person 3 to read. Okay, 1 second. Person 3 to read, person 2 to write. Now what we have done is, here is one name object. We have allowed person 3 to read first. We have made this person 2 to wait for 1 second. We have allowed person 2 to wait for 1 second and to allow person 3. Suppose when we execute, if there is no other abstraction, obviously a thread will execute without any abstractions if there are no abstractions. Okay. Now here, person 3 is also doing the same. For the person 3 thread, there is no disturbance. Person 3 is reading the data and going. After that, after 1 second, person 2 will come, it will edit the data. So when it is editing, after editing, it goes, and now the current name should be the return name. Whatever the return name means there, no, inside that name object, it should be there. This is happening by making it wait for 1 second. This is happening because we are making it wait for 1 second. Okay. So now after we made it wait for 1 second, now if you're printing the name in the main method, t.name variable, task.name variable, you have to get the updated name. You should not get the old name. You have to get updated name. Okay. Current name is Rajnikant. Changed name is Likita. And the main method name, whatever there in main method, okay, that name should be Likita. Okay. Now, if in the main method the name is Likita, the updated mean, then we have achieved this name object changing. Okay. One thread we have assigned to read and one thread we have assigned to write. So for writing thread, we made delayed by 1 second. For reading thread, we allowed to read. So reading thread read data and went off. After 1 second, writing thread came, edited the original variable name. After that, inside the variable name, there is a changed data. So inside main, that is the same data you are getting. Okay. Same data you are getting. Okay. So this is about the name object. I hope you guys have understood. You guys got an idea what the threads are doing, everyone? Guys, did you get it? Have you understood? Am I audible to you all? Okay, if you have not understood, go through the program, execute, and understand. Practice. This is, I know this is little tricky for you, but it's very easy. Yes, you have to revise, then only will get it. Okay, at least you guys have one rough idea how this is working. What about others? See, what's happening? Okay, let me explain you 1 second. 1 second, I'll explain you. Listen very, very carefully. Okay, so what's happening here is, we have allocated one thread 1 to read the data, read the name object, and the thread 2 to write the data or change the data. So thread 1, thread 2, both parallelly, both are acting upon the name object. Data will be insufficient. So you will not get a proper output. So what we have to do, we have to synchronize properly. Synchronizing means thread 1 is coming here, it is reading the data, it is going. Thread 2 is coming here, writing data and going. But here what happened, we have not made anything wait. So what happens, both are executing parallelly. Either this thread, writing thread can execute first or reading thread can execute first, we can't tell. At a time, only one object. Now, this name object will take only one object at a time, one thread only at a time it will take. But we don't know whether it's a reading or writing. Okay. Now, to know it's reading or writing, we are making the writing wait for 1 second. Let the reading read the name and go. After that, writing goes, change the name and go. Now, the current name, whatever is there, is the updated name. Updated name. Okay. So, this is about the data inconvenience. At least now you guys got it. Everybody? You guys understood? Okay. So today is the last day and it was a great time with you guys. Yes, 12 of you are here. Okay. So this weekend, okay, this Saturday you will have a designability test. Okay. Saturday you'll have designability test and Sunday you will have the programming test as well as the MCQ test. Okay. Yeah, same time, no problem. 7 p.m. Yeah, fine. So Saturday you will have a designability test. Only one design I'm gonna give you. 2 hours. Take complete time. Execute. Okay. So 2 hours. Do the design. Saturday. Sunday. Same time. 7 p.m. Or okay, fine. 7 p.m. only. So guys have to go for MCQ test. Meanwhile, the logical questions also I'll give you. Make sure you execute and come. I mean, you attend that. Okay. Okay, guys, that's it for today and forever. I will never take your class again because today is the last day. Mock later I will take in the Google Meet. Whoever has attended, listen carefully. Simply, I will not take mock for you. Okay. If I want to take mock for you, your MCQ should be done, designability should be done, programming should be done. Okay. So at least instead of programming, I shall give you only MCQs on Sunday. Okay. So programming and the oral mock will combine and will have in one Google Meet. After attending that, I will tell you. Okay, who has to attend what. Okay, when I will allot you some timings and I'll give you. You can join during that time, attend the mock, and you can leave. Okay. So Saturday 7 to 9, 7 p.m. to 9 p.m. designability test, and Sunday 7 p.m. to 9 p.m. you will have a MCQ test. So based on that both, okay. So tallying that both, whoever has attended both, for them I'm gonna give mark. I don't care if you have failed or if you have passing mark. If you have attended, I'm gonna give you the mock rating. Okay. If you're not attending, surely I'm not gonna give you a mock rating. Okay, you have to attend. So if you have not attended part 1, part 2, it's okay. Attend part 3, that is final test. So this Sunday, I mean this Saturday, what is the date? This Saturday, 28th. Okay. So 28, 29. 28, 7 p.m. to 9 p.m. you will have designability test. And 29, 7 p.m. to 9 p.m. you will have MCQ test. After clearing both, on Monday or the next week, I'm gonna allot you guys, okay, 15 minutes or 20 minutes each. I'm gonna give you one Google Meet link. You can join, attend the mock, and you can go. Okay. Mock test I have not scheduled yet. Okay. First attend these 2 tests. Okay. Then I will schedule for you because I don't know how many of you will attend out of 13. Okay. So based on whoever has attended,